Hi, today I'm going to start talking about solids revolution again, okay? So let's talk about this thing here first. This is going to be like y equals f of x. So y equals f of x makes this curve, all right? And we're going to talk about two ways of forming a solid revolution when it rotates about the x-axis. So this graph right here, it's rotating this way, okay? Around the x-axis. All right. So when you do that, how can you form a solid revolution this way? Well, I mean, how can you calculate the volume of the solid revolution? Well, you can create disks with this radius, okay? So this is going to be a radius over here for this x. This is going to be another radius. This is going to be another radius. So what's going to be the area for this disk in here? It's going to be pi r squared. And what's going to be r? It's going to be this length, okay? For this disk in here, it's going to be, let's just say, call this 1, 2, 3. So for disk 1 is going to be r1. For disk 2 is going to be r2 squared. For disk 3 is going to be r3 squared, okay? All right, so this is going to form a disk that's going to rotate this way, all right? And then you're going to calculate the area over here. And this is going to form another disk, and it's going to rotate, and you're going to calculate the area over here. Okay, but there's another way that you can do this too, and it's with the shell method. The shell method, instead of integrating, you see the rotating axis in here is the x1. The rotating axis in here is still the x1. You still want to get the same shape. I know it's not exactly the same, but you want to get the same shape and you want to rotate it around the x-axis. But in order to calculate the volume, one thing that you can do is to get this bar, instead of having vertical bars, you're going to have horizontal bars parallel to the axis of revolution. So how are you going to do this? Well, you're going to get this length right here, okay? And you're going to do like 2 pi times this distance here, the distance from this horizontal bar to the x-axis, which is just going to be y. And then you want, in this case here, you're integrating the disks with respect to x, okay? There's a disk in here, there's a disk in here, there's a disk in here, disk, okay? So you're going along the x-axis. Over here, you're going along the y-axis. All right, so you're going to have to calculate f of y. That's going to be, for example, this point in here of x, because you got to remember one thing, guys. Y equals f of x and x equals f of y, okay? So you want this x minus this x, and then you're going to multiply. So let's just say that so you see what the problem here is? You're going to have to partition this thing right here, okay? And then you're going to have to call this function f of y and this function here g of y. And then it's going to be 2 pi y. Why is it y? It's this distance here, okay? The distance from this bar here to the x-axis. 2 pi y times this length. And what's going to be this length? It's going to be f of y minus g of y. Okay? So you're going to do it like that. That's for this one. So when you get this bar and you rotate it around, you're going to create a shell, like a cylinder. Okay? And then you create a cylinder with an infinitely small, larger radius. And so you're creating a shell, and around that shell, you're going to create another shell, and around that shell, you're going to create another shell, and all these shells are infinitely packed tightly together. This way, you're going to form a solid too. But how do you know whether you're going to use the disk method or the shell method? Well, it depends on the axis of revolution and on the shape of the function curve that you're going to rotate about the axis, okay? This one here, the best thing that you have to do, and for this one here too, the best thing that you have to do if you want to rotate it around the y-axis, if you want to rotate it around the x-axis like this, okay, is to, okay, I'm going to do it like that. If you want to rotate these two shapes, the best thing that you have to do is to use the disk method. So you don't have to figure this stuff in here out, f of y minus g of y. All you got to do is to use f of x, okay? Let's just say that you're using the disk method. Erase the stuff in here. In here, for example, this is with the shell method. So this is with the shell method, okay? Method. Okay, let's try doing the same thing here with a disk method. Well, in this case, you're not going to have g of y and f of y. You don't have to partition this in the middle like this. All you got to do is to consider this whole thing in here, this whole curve, y equals f of x, all right? And then you have to do pi f squared of x dx, the integral. Okay, from this point, which is 0, all the way to this point here, which is a, for example. So a, it'll go from 0 to a. Now over here, you're going to have to do something different. You're going to have to figure out what the top in here is. So this is going to be like the point B. And then you're going to have to, well, let me think. Yeah, from the point B to A, you're going to have to use, well, f of y. No, actually, you don't have to find the point B. Okay. All you got to know is, for example, because this function doesn't have an inverse, how do I know that? It passes the vertical line test. Okay. The vertical line test touches the graph only once, but it doesn't pass the horizontal line test. You see here, it's crossing twice, over here and over here. So you're going to have to figure out how long this thing is. So for each value of y in here, first you're going to have to figure out how to get f of y, which is this value of x for this y, and the g of y, which is this value of x for this y. And then for the next y over here, you're going to have to find the new f of y, which is going to be around here, and the g of y, which is going to be around here, and take one minus the other. Okay, and so that you can make the shell method in here. That's gonna make it more complicated. I mean, this stuff in here is a lot simpler than this. Okay, now and there's something else too before I change the axis of revolution. In the disk method, the bars, these red bars in here, they're going to be perpendicular to the axis of revolution. So the axis of revolution here is x, and the bars are perpendicular. This is in the disk method. In the shell method, the bars are parallel to the axis of revolution. So if it's the horizontal axis, if that axis is the axis of revolution, then the bars have to be horizontal too. Okay. So in here, you're creating a disk like this, and you're putting another disk in here, and another disk, and another disk, and another disk. That's why it's called the disk method. Okay. Now, in this one over here, actually what you're creating is a shell. You're going to create a shell here, and then you're going to create a shell here, and then you're going to create a shell here. Well, like I said, what are these shells? They're cylinders. Okay. Now, pretend that your eye, I don't know how to draw an eye, like maybe like this. I don't know if this is an eye. Maybe it's too small. I'm gonna make a bigger eye in here, like that. I don't know. And then you have these, right? The little hairs of the eyelids, and you got an eye here. So let's just say that you're looking this way. Okay, you're looking parallel to the x-axis. What are you gonna see? You're gonna see a cylinder with a radius of 0, and then another cylinder this way, and another cylinder packed around here, and another cylinder packed around here, and another cylinder going around the x-axis, and another cylinder going around the x-axis, and another cylinder going around the axis. You see, you're forming a solid in here. This is a solid. That's what's happening over here with the shell method. You're creating a shell, and then around that shell another shell, and then around that shell another shell. Okay? So in the disk method, the bars are perpendicular to the axis of revolution, and you are integrating according to the axis of revolution. In the disk method, meaning dx, okay, you're going to have a dx in here for this disk and this disk and this disk and this disk. Now for the shell method, you're gonna the bars are going to be parallel to the axis of revolution, and because the bars are going up, you're actually integrating with respect to dy. Okay, it was going to be like the integral from 0 all the way to this value of y here. I'm just going to call this b. Okay, so this is going to be b dy. That's what you have to do. So you see that the axis of revolution is x, but the bars are parallel to the axis of revolution, and you're integrating with respect to y. Okay, now let's think about this thing here. If you were rotating with respect to y, for example, now look at this shape, and I'm rotating it like this. I'm rotating it around y, not around x anymore. Now, what is going to be the best way? The shell method or the disk method? Well, this is the axis of revolution. So the shell method, the disk method is going to use bars that are parallel, right? Not that are parallel, that are perpendicular to the axis of revolution. Here you got the same problem that you had in here. You're going to have to find out, for example, let's put a horizontal bar here. You're going to have to find out this x minus this x. Okay? That's what you're going to have to do in the disk method. And you're going to be integrating with respect to y. So it's going to be this disk going around, and then another disk in here going around. But that's not the way the disk method works. Okay? You're going to have to make this point in here go around and make a big disk, and then you have to find out this little disk in here, make it go around. Okay, so remember, this is like the washer method that we saw. In order to make this go around the y, this shape in here go around y, you're going to have to do like the integral, right, from whatever to whatever. For example, just say a to b, not this a and b here, just something, guys, just I don't know, maybe c1 to c2. Okay, of what? Well, it's the axis of revolution is the y1, and you're using the disk method, so I know that this is going to be a dy. But then you have to find out this value of x for this value of x. What are you going to have to do? You're going to have to do like pi r, big R squared of y minus little r squared of y. That's what you're going to have to do, because there's a hole. Imagine that this here, it's not going around the x-axis anymore. Now it's going around the y-axis. Okay, there's going to be a hole. All this place in here, it's going to be like a funnel. Okay, you're going to have a solid in this area, but in this space in here, there's not going to be anything. It's a hole in the solid. So how do you create the hole? You use this method, right? Now let's just say that instead of using you want this shape to go around the y-axis. Instead of using the disk method, you want to use the shell method. Okay, so you're going to be integrating with respect to dx, because the axis of revolution is y. You're using the shell method, so you're going to be integrating with respect to dx, and the bars are going to be along the y. Okay, now it's easy. All you got to do is to do exactly what you're doing in here. Y is equal to f of x, and you go from 0 all the way to this point here that we can call, for example, c2, right? And you're just going to keep going. But is it going to be the disks? No, because it's not going around here. Okay, it's just going to be this bar going around and making a cylinder. Now this bar going around and making a cylinder. Now it's this bar here, it's going around and making a cylinder. So you see, you have to analyze the shape of the function curve, and you have to analyze the axis of revolution. Okay. Now, just as a, I don't know if I want to create some kind of, let me just see here if I want to create some kind of table like this, just a very crude table, right? And let me just do this, maybe this, maybe this. I don't know if I'm going to need all these cells. I just want to create some kind of crude table in here, like, okay. So let's think. I'm going to put it over here. You have the disk, and here you have the shell. Okay. Now, in here, I'm gonna say like the axis of revolution. Just a little scheme here. Okay. Over here, I'm gonna do variable of integration and the bars. The bars, what bars? What am I talking about? I'm talking about these red things. Okay. Now let's see. I don't even know if this is the best way to do this. Not yet. I'd say that I want to drag this thing in here. I want to drag this in here. I want to drag this in here. Yeah, I think it'll be better this way. So let's think here for a second. In the disk, okay, for the disk method, what's going to be for the axis of revolution? Oh yeah, that's right. Axis of revolution is going to be here, and the disk is just going to be there. So no, let me just put this thing like that. So for the disk method, okay, disk axis of revolution, adverb integration, bars. Yeah, okay. Anyway, it's just not working. Let me see here. Let's just say that the axis of revolution here, you only got X and Y, okay? Let's forget about the Z for a second. Now, in the disk method, yeah, I didn't know how to make the scheme, guys. I'm sleepy, okay? So for the axis of revolution, you're going to have twice. Anyway, whatever. Here, the variable of integration. Okay. I'm just gonna make another scheme, guys. For example, disk. Okay. So, for the axis of revolution being X, axis of revolution being X. Gotta make this huge in here. The axis of revolution being X. What's going to be the variable of integration? Well, it's dx, okay? That'll be the variable of integration, and the bars, because the axis of revolution is X, the bars are going to be vertical bars. Okay. Now for the disk method, axis of revolution being Y? Yeah. No, actually no. Now the shell, okay, axis of revolution being Y. No, being X. Yeah, that's better. So what's going to be the variable of integration? It's going to be dy. The bars are going to be along the horizontal axis, so you have horizontal bars. Okay. And now for disk, axis or revolution being Y. So, yeah. For the disk, the axis of revolution being y, you're going to be integrating with respect to y, okay? You're going to have horizontal bars, and that's it. Now for the shell, axis of revolution being y, right? You're going to integrate with respect to dx, and you're going to have vertical bars. It's like a little messed up scheme that I made in there. Let me think before I get this out. In a disk, the axis revolution being x, and you're gonna have all those disks stacked along the x-axis, and the bars are gonna be vertical. If you're using a shell, the axis of revolution being x, you're gonna be integrating with di with horizontal bars. This is right, and the thing is the opposite. So y dy, vertical bars, horizontal bars, shell, axis of revolution xy, dy, dx, okay, and vertical bars. Yeah, this is something that you can like memorize. I don't know. Okay, forget about this stuff. I try to make some kind of Excel spreadsheet out of it, and it didn't work. So put it up there. Yeah. Now let's think about this again. Axis of revolution being x. Okay, so you're going to be integrating these disks in here with respect to dx, the vertical bars. Now, axis of revolution being x with a shell, it's over here. Okay, you're going to be integrating with respect to y. Why? Because the bars are not being stacked to the side. They're being stacked on top of each other. So you're going to be integrating with respect to y, and the bars are horizontal. And if you want to do axis of revolution being y, all you got to do is to do the opposite of all this. I hope it's clear, guys. It's kind of weird, okay? Just to finish this thing, I think it's finished enough. Hold on, just one little thing here, just one little reminder. So if I was going to stack, if I was going to find the solid revolution of this, okay, around the x-axis, I was going to have, using the shell, around the x-axis using the shell, I was going to have to do this, okay? Now, around the x-axis using the disk, I was going to have to do this stuff in here. Using this formula here that I erased. Using this formula here. Okay? The thing is, the general formula, what I'm trying to get to is the general formula, the disk method. The general formula is pi integral of r squared of x dx, if it's going to be around the x-axis. Okay, the shell around the x-axis is going to be 2 pi, all right, the integral of f of y dy times the y. You got to have another y in here. Why do you have to have another y? Okay, this f of y is going to be the length of these bars, how long they are. This y here is going to be the distance. Okay, for example, this distance for the top bar, this distance for the middle bar, this distance for the top bar. Because what you're doing is a shell, right? So how do you know the area of a shell? Well, you do 2 pi. Why 2 pi? Because it's going around something. If it's going around something, it's going to be 2 pi. Okay? And what else? Well, you need the radius, right? Because if the radius is 0, it's nothing. So a larger radius is going to create a larger shell. So you have 2 pi r. But not only that, you have the 2 pi r, you also have this length in here. So you have to multiply by this length. This length is going to be f of y. Okay, so this is the general stuff. But of course, when you're trying to do the washer method with either one of these methods, then you have to account what is the Washam method when you have a hole, right? For example, you want to rotate this curve, this function curve, or this function curve in here around y. This whole area is going to be a hole. This whole area in here is going to be a hole, okay? So what would you have to do? In the disk method, you're going to have to get this value squared minus this value here squared and, multiplied by pi. Plus this value here, okay, minus this value here. So that's the way it's going to work. That's why you have to really analyze these things, okay, to find out which method is the best for each one of the shapes of the function curves. And you have to analyze around which one of the axes it's going to be. Okay, I mean, graphs like this are perfect to go around the x-axis, right? For the disk method. Now, if you're going to make it go around the y-axis, you don't want to use the disk method. Then you want to use the shell method, right? Because it's a lot simpler. You make this shell here. This is going to be f of y, this distance. This distance here is just going to be, well, in this case, because it's around the y, okay, this is going to be f of x. This is just going to be the value of x. So it's going to be, for example, just for this one cylinder here, how are you going to find out what it is? Well, it's 2 pi times this distance, okay, so I'm going to call it x, times this distance in here, which is what? F of x, for this x in here, okay? But what about for the next x? Well, for the next x is going to be the same thing, 2 pi, that value of x, times the f of x for that x. It's going to be this, all the stuff. And if you want to rotate this or this around the y, the shell method is the better. Now, if you want to rotate this and this around x, the disk method is the better. And that's it, guys. We're going to do some exercises on the next video.